So, welcome back, students. Welcome to the lecture series on signals and systems. This is a continuation lecture for the energy and power signals, where I would like to prove that the power of the energy signal is zero over infinite time, and the energy of the power signal is infinite over infinite time. Okay, I'll just write this for you. Okay, I would like to prove this as the power of energy signal is zero over infinite time. Let us prove this first and then proceed for the other condition. Okay, I would like to just calculate the power of the energy signal, and it is I would like to show that it has zero. Let x of t be an energy signal. Okay, x of t be an energy signal, and that is nothing but E, the energy of this particular signal, integral of minus infinity to infinity modulus of x square of t dt will be finite. This is finite. That means it is less than infinity. Therefore, if I would like to calculate the power of this signal P, which is given as limit t tends to infinity 1 by 2t integral of minus t to t modulus of x square of t dt. This represents the power of that x of t. But as we know, just since this is considered, I would like to write this as I would like to just, as you know, that the power is given by energy per unit time. This can be simply written as limit t tends to infinity 1 by 2t into E. Okay, since this represents the energy of the signal, I can write that it as E. Therefore, when I substitute this with E, I could see that this value of limit t tends to infinity 1 by 2t becomes 0. Therefore, 0 into E will be always equal to 0. Thus, the power of the energy signal is 0 over infinite time. Okay, that is what I have written here. The power of the energy signal is 0 over infinite time. And similarly, I would like to prove one more point, that is the energy of power signal. Energy of power signal is infinite. Power, the energy of the power signal is infinite over infinite time. This is the second statement that I would like to prove. And in the same way, now I consider x of t to be a power signal. As we know, for a power signal, the average power P is finite. That is, limit t tends to infinity 1 by 2t integral of minus t to t modulus of x of t square dt is finite. That is, it is less than infinity. And you know that the energy of the signal is given as integral of minus infinity to infinity modulus of x square of t dt. You can write like this, the energy of the signal. Let us change this limits of the integration of this energy from minus t to t, minus capital T to capital T, and take the limit as t tends to infinity. I just write this as E is equal to limit t tends to infinity integral of minus t to t modulus of x of t whole square dt. Okay, modulus of x of t whole square dt. Therefore, you could see that this can be written as limit t tends to infinity, and I just try to multiply and divide with a value like 2t, so that I can see that 2t into 1 by 2t into integral of minus t to t modulus of x of t whole square dt. And this can be further written as just try to take out the terms and try to represent it as, okay, I just represent it as limit t tends to infinity 2t into limit t tends to infinity integral of, okay, 1 by 2t integral of minus t to t modulus of x of t whole square dt. This actually represents the power. This represents the power of the signal, and therefore you could write this as limit t tends to infinity 2t into, this could be represented as the average power of the signal, therefore I represent it as p. But as we know that this particular limit actually, when substituted with t tends to infinity, this tends to infinite. Therefore, infinite into p gives us an infinite value. Thus, the energy of the power signal is infinite over infinite time. Okay, that is what I have said. Thus, the energy of the power signal is infinite over infinite time.